The lymphatic system is, well, it's a parallel flow of blood occurs along our cardiovascular system. You don't hear about the lymphatic much. It seems like the cardiovascular gets all the attention. But let's take a look at this. We have blood flowing from our capillaries into the lymphatic vessels. So here we have this parallel tube that's going to capture some of that lost fluid and move it back to the heart eventually. But let's see what's going to happen, because there's a purpose here in the body's wisdom. At these lymph nodes that are distributed throughout the body, there's going to be fibers in here, and they're going to trap foreign material like viruses and bacteria. And then we have T cells that are going to destroy them. Thank goodness. So once they're destroyed, now we have sort of filtered, purified blood that's going to return back into the circulatory system. It works most of our lives almost perfectly. Red bone marrow, that's where all blood cells are made, including B's and T's. I'll talk about these. T's are transported to the thymus, which you don't hear much about the thymus, located here in the cardial region. In the innate immunity, which is the first, well, it's really the second step. When we're infected, we have surface tissues, then we have this innate immunity. And they're going to attack everything that doesn't belong if it's a foreign protein. And one of the keystone cells here is the dendritic. And the dendritic means sort of tree-like, and they have long branch projections. And they're going to capture anything that doesn't belong. And here is a good dendritic cell. You can see the long arms. Once they consume something, which is here indicated these little red rods, then they're going to stimulate what's called adaptive immunity. And adaptive just means that these are the cells that are built to detect and destroy one type of organism. Okay, so the dendritic is attacking everything, but they're conveying the message, hey, we're under attack, and this is the surface protein they're wearing. Now the helper T's are going to, let's see, helper T's, they're going to release cytokines that tell the body we're under attack. Because we don't want to be in a constant stage of defense, because that's exhausting. And so we wait until we get these cytokines. And then we're going to produce lots of white blood cells in the red bone marrow. Now the cytotoxics are going to destroy, and here we have an upper diagram. When a cell is infected, or the organism itself, they're going to release these perforins that are perforating or poking holes into infected cells. Really quite marvelous. We have these APCs. In this case, a macrophage is an APC. Anything that eats an antigen, antigen means a foreign substance. Now you see this little bar on top? That's a surface marker. We have our own surface markers, self markers. In this way, our body can tell self from non-self. And then we know what to destroy. So APC or a macrophage eats this, and then it's going to display the antigen's marker. B cells, they're going to tag it. You see these Y-shaped things. When something's foreign in our body, they tag it, and that makes the macrophages go crazy, and they eat them even faster. So the B cells and T cells kind of work together. A lot of writing here, but it's pretty simple, really. Here's that APC macrophage, and here's the foreign marker. I put it in orange if you're watching color. Now a T cell comes along, and remember this is part of the adaptive, and so the T cell is going to say, hey buddy, what's going on? Hey, we're under attack, man. Here's what they look like. Okay, let me get a copy of that so I know what to look for. All right, man, you got it. Okay. Now we also produce these memory cells, which I've written here, memory T cells, and that's why we don't usually get the same infection twice. So if we get sick and then that person that got us sick, sneezes in our face, a couple weeks later we can just laugh because, hey man, I got memory cells, I'm covered. And that's why we have vaccines. Vaccines are amazing because what vaccines do is they alert the T cells to recognize like a specific flu virus or whatever it is, and without us getting sick, because we just use yeast or something harmless. Now some people say, oh, I got sick when I got the flu shot. Well, they were probably already getting sick, and then the flu shot does give you a little suppressed immunity. It might last, a day, day and a half. And so if you're already getting sick, then that just kicks you over the edge. But the flu shot doesn't get you sick because the flu shot can't. It's just a surface marker. It's not we don't inject viruses into people. Speaking of viruses, again, a lot of writing, but it's pretty simple. Let's take a look. Upper right, we have the HIV virus. It's going to attach to a helper T cell. And we need these guys, right? The helper Ts. Remember, they produce the toxins, and so it's kind of unfortunate that the HIV attacks one of the most important defense cells in our body. Now they're going to use this reverse transcriptase to attach, look to the center, they're going to attach to our DNA. And now we have a genetic disease. And that's why many people they're upset. Hey, we can't find a cure for AIDS. Well, yeah, because you know what? It becomes a genetic disease. So it's not just like I'm not just Joe. Now I'm Joe and part of a virus because it's a genetic component of our DNA. Okay, it uses this reverse transcriptase. I mentioned that, and it also is going to trigger. So it's laying there quietly, and it's every time this cell reproduces, this is us, then that copy is made. So after a while, we may have millions of copies of the cell, and then a triggering event occurs, maybe their first cold, whatever it is. Could happen months after the infection. And now we have this protease enzyme is going to make more HIV, and we see now number 6 and 7. The HIV is released by the millions, and suddenly maybe 3 or 4 months after initial infection, we have the outbreak, and the victim is going to start feeling the symptoms of this disease. That is a permanent. Don't fool yourself. The world's not as safe as you think. We see these Hollywood movies with people having lots of sex. What we don't see is that things get transmitted. Some of the treatments include the reverse transcriptase, which is going to block the HIV from attaching to our DNA, and the protease enzymes, which kind of stops the production of HIV. Back to the lymph nodes, they're scattered throughout the body. We saw that nice video. Heavy concentrations around the neck, the axillary regions, the groin. I mentioned the filtering that they do. There's these reticular fibers that are going to trap foreign material, bacteria, viruses, and within the sinus area here. And then macrophages and APC, which really a macrophage is an APC. They're the ones that, if you remember, they consume the bacteria and display the marker so the T cells know who to attack. In this way, the blood that leaks from the blood vessels returns to the heart. We saw that in the video. Edema is just swelling, but why does it occur? Well, let's take a look at this. This is a slick diagram. Let's say we have an injury or exposure to an allergen, whatever. Well, our body is going to release lots of plasma, and this lower part here is a capillary. Now, capillaries are bizarre because they have really thin walls, and so when we're under attack, they kind of break apart and they're leaky, and so plasma fills the space, which we want because plasma is loaded with B cells, T cells, and macrophages, all kinds of APCs. So this is exactly what we want. Plasma proteins I mentioned. Okay. Allergy medicines. When we do have a severe allergy, the most medicines contain an antihistamine agent because this whole process of edema is often triggered by damage and the release of histamines by our own body cells. Problem is, many cold and flu remedies like NyQuil and there's so many cold medicines. I don't like to call them medicines. And the problem is, okay, think of this. They're going to shut down edema, and so now your nose doesn't run as much and your sinuses aren't so swollen and you're starting to feel better. But what's happening? Think about this. These bacteria are multiplying and there's nobody there to stop them. So I don't recommend cold remedies unless you feel like being sick for like longer than you have to. We want that swelling. We want a runny nose, because what that's telling us is, yes, our defenses are in full gear, top gear here, and T cells, B cells, macrophages, APCs, they're all in full battle gear, and they're protecting us. And if you take that cold medicine, yeah, you feel good, but these bacteria are happy too, because they're going to spread into the lungs, and this thing's going to go on for weeks. So unless you get, sometimes sinusitis, if you get sinusitis, maybe a little antihistamine or something before bed so that fluids don't back up into the sinuses. So there is a time for cold medicines, but mostly not. Anaphylaxis, okay, shock, we always think of shock as being the serious part, but shock begins with type 1 anaphylaxis. And here we just have histamine, which I've talked about a lot just now. And we have these mast cells, and take a look at the far right. When they encounter an allergen might be something harmless like pollen, then histamines are released and our body thinks it's under attack, but it's not. And so we're fighting a harmless substance. We also have smooth muscles contracting, which are going to affect local airways and sometimes be life-threatening, especially in, this should say type 2 type 1 reactions will lead to shock. Because think about this, all the plasma that's flowing out of the bloodstream is now in the tissues, and that's good. Okay, well, it can be good if we really have a bacterial infection. But the problem is the blood is going to get thickened. It gets almost like syrup, and that increases the workload of the heart. And of course, the airway is going to get, and this is typical, the swollen lips and puffy eyes, often an allergic reaction. Injection of epinephrine will dilate those airways and strengthen the heartbeat. Spleen, you don't hear much about the spleen. It's basically a huge lymphatic vessel, it's multiplied. It contains those T and B cells, so very valuable. If we ever get a rupture, there's pain here in the anterior chest region. Hopefully we can keep that spleen, because a splenectomy is going to reduce the amount of T and B cells we have available to fight infections. Now the liver and the red bone marrow are going to step up their production, and they'll lose some of the workload, but these people are always going to be a little bit immunosuppressed. On with the lymphatic tissue, we look at the throat here, the tonsils. We have the pharyngeal, or sometimes called adenoids, that are deep. And there's the palatine tonsils here that sometimes you'll see speckled with white, especially if someone's fighting a upper respiratory tract infection. Lots of crypts where our body has opportunity to trap organisms. If you have tonsillitis, infection, look at that itis suffix. Usually it's a viral infection that progresses into a bacterial, and we get the sore throat, difficulty swallowing, and these tonsillar nodes are going to swell. Tonsillectomies are often done only after like lengthy antibiotic treatments, or if we have a threatened airway, and then we don't have an option really. We've got to save the life. Breast cancer. Let's look at this diagram here. Most cancers start in the upper lateral quadrant. Okay, so we're in the upper lateral here near the pectoral, and there's a specific drainage pattern which is helpful when we're diagnosing breast cancer, because that's where we can look at these sentinel nodes, and instead of just going in and just traumatizing all the nodular material, we can just sample some sentinel nodes and track the direction. We hope we don't see metastasis, and that's when it spreads. We have distant metastasis is where it's going to spread to different organs, lungs, liver, bones. It tends to first spread to the closest, so the lungs here, liver, but it'll keep moving. How do you know the difference? Cancerous nodes tend to be enlarged, and they're not tender. They're just swollen, fixed in place, whereas infected nodes tend to be soft, tender, and movable. And so if you're a woman listening to this, remember your annual mammogram.